The objective for this video is to teach you how to solve radical equations. A radical equation is basically any equation that contains a variable inside the radical symbol. So if you're taking like the square root of x or the fifth root of y. So there are some basic steps that you want to follow to do this. You want to make sure you're doing these in the correct order. The first step is to isolate the radical if it's possible. You're going to see in some cases it's not going to be possible to do that, but if you can get the radical by itself, then you definitely want to do that first. Next, you're going to raise both sides of the equation to the power equal to the index of the radical. What that means is the third root, 3, is the index, so I want to take both sides to the third power. If this is the fifth root of x, then I want to take both sides to the fifth power. And then when you do that, the third root and the third power are going to cancel out, and then you'll be able to solve your equation. So we're going to do quite a few examples to give you a variety of what you might see on your homework. So remember, step 1 is to isolate the radical if it's possible. So here I have 2 times the square root of x plus 1 equals 14. I just want the square root part by itself. So since this is 2 times, the opposite of multiplication is division. So I'm going to divide both sides by 2. When I do that, I get x plus 1 equals 14 divided by 2 is 7. The next step is to raise both powers to whatever the index or root is. So this, because there's no number, makes this the square root. So the index is actually 2. So I'm going to raise both sides to the second power. When I do that, the square root and the square cancel out, so I'm left with just x plus 1, the radicand, on the left. On the right, I have 7 squared is 49. Now my last step is to solve for x. So I would subtract 1 from both sides, and I would get that x equals 48. It's important that you check for those extraneous solutions. Extraneous solutions are any number that x is equal to, but it's not allowed to be equal to. So here, if I plug 48 back into my equation, 48 plus 1 is 49. The square root of 49 is 7. 7 times 2 is 14. Since that is true, then this is the correct answer. So x equals 48. Alright, so we're going to do another one where we're going to isolate the radical first. Here, since it was 2 times, we divided both sides by 2. Now it's 4 plus, so I'm going to subtract 4 from both sides. I'm going to get the square root of x plus, or x minus 1 equals, when I subtract 4 from both sides, it's equal to 1. Next, I'm going to raise both sides to the second. The square root and the square cancel out, so I have x minus 1 equals 1 squared is 1. Add 1 to both sides, I have that x equals 2, and now I need to check my answer. 2 minus 1 is 1, the square root of 1 is 1, 1 plus 4 is 5, that is true, so this is my answer. So you've done examples like this in the past where you've just been working with square roots. Now we're doing the same thing, but we're going to do the cube root. So we can do this for any root. We want to isolate the radical if we can. It's already isolated. Our next step is to raise both sides to whatever power matches the index. So the index is 3, so I want to raise both sides to the third power. And the reason why we do that is because the third root and the power of 3 are going to cancel each other out. So on the left, I just have 3x minus 4. On the right, I have 2 to the third, which is 8. Now my last step is to solve this equation for x. So I would add 4 to both sides, get that 3x equals 12. Then I would divide both sides by 3 and get that x equals 4. Before I say that this is my final answer, I have to check it. So when I put 4 in, 3 times 4 is 12. 12 minus 4 is 8. The cube root of 8 is 2, and 2 is equal to 2. So that's a true statement. So this is now my final answer. Alright, so what do we do when we have radicals on both sides? Step 1 said to isolate the radical, and I told you that's not always going to be possible. So here's an example where it's not possible to get the radical by itself because there's one on each side. So now we move on to step 2. Raise both sides to the power that matches the index. Since there isn't one written here, then that's automatically square root, so the index is 2. So I'm going to raise this side to the second power, and then I'm going to raise this side to the second power. So you have to square everything. Over here, the square root and the square cancel out, so I have 35x. The step that everyone forgets is that you have to square the 5 as well. So this would be 25 times, when I square the square root, they cancel out, that's x plus 2. And now I have to distribute the 25. So I have 35x equals 25x plus 50. When I subtract 25x, I have 10x equals 50. Now I'm going to divide both sides by 10. I get that x equals 5. Now I'm going to check my answer. When I put 5 in, 35 times 5 is 175. So I'm going to go do my check on this one over here. So I have the square root of 175 equals 5 times the square root here. 5 plus 2 would be 7. And it may not look like these are equal, but I'm going to simplify this. 25 goes into 175, and 25 is a perfect square. It goes in 7 times. The square root of 25 is 5, so I have 5 square root of 7 equals 5 square root of 7. That is a true statement, so now I know that x does, in fact, equal 5. So I want you to go ahead and try one on your own. So when you finish the problem, go ahead and hit play to check your answer, but right now I want you to pause it. Alright, so hopefully you've had some time to finish this problem. So what you should have done is taken both sides to the power that matches the index, which was 3. Hopefully you also remembered to take 2 to the third power. On the left, I have x plus 6. On the right, 2 to the third is 8 times x minus 1. I have to distribute the 8. So I have x plus 6 equals 8x minus 8. I'm going to subtract 8x, so I have negative 7x, because x minus 8x was negative 7x. Subtract 6, so negative 8 minus 6 is negative 14. Then I'm going to divide both sides by negative 7, so x equals positive 2. And now I substitute that back in. When I put 2 in here, I have 2 plus 6 is 8. The cube root of 8 is 2. Over here, 2 minus 1 is 1. The cube root of 1 is 1. 1 times 2 is 2. So I have 2 equals 2, which is true. So x equals 2. The other types that you're going to see is a rational exponent. Now you could go ahead and rewrite this. So this would be the fifth root of 3x minus 1, and then it would look like all of the other problems. But one of the properties of exponents that we've talked about is that a power raised to a power, you multiply the exponents. So I'm going to use that to help me. So if I have 3x minus 1 to the 1/5, I want to raise this to a power. And I'm always going to choose the reciprocal, because when you multiply two reciprocals together, you get 1. So the reciprocal of 1/5 is 5 over 1, or 5. So now I have a power raised to a power. I would multiply these exponents together. So 1/5 times 5 is 1. So on the left, I have 3x minus 1 to the first power, which is just 3x minus 1. Since I raised the left side to the fifth power, I have to also do the same thing to the right side. So now I have 3x minus 1 equals 2 to the fifth, which is 32. Now I'm going to add 1 to both sides, so I have 3x equals 33. Divide both sides by 3 and get that x equals 11. And now I need to check my answer. When I put 11 in, I have 3 times 11 is 33, minus 1 is 32. 32 to the 1/5, if you think about that. 32 to the 1/5. That's the same thing if I were to rewrite it as the fifth root of 32 to the first. So the fifth root of 32 is just 2, and that's what I have. 2 equals 2. So I know that x does equal 11. So here's another example that I want you to try on your own, just a kind of a reminder on this. You want to get the radical, or in this case, the rational exponent by itself, so you will need to divide both sides by 3. That's the only hint that I'm going to give you. So I want you to go ahead and pause it and play it when you're done. Alright, so again, I told you you're supposed to divide both sides by 3 first. So that would give you x plus 6 to the 1/2 equals 9 divided by 3 is 3. So you could rewrite this and make this the square root and then take both sides to the second power. Or you can multiply 1/2 and 2, the reciprocal, and get 1. So I'm going to raise this, a power raised to a power. The 1/2 times 2 is 1, so on the left I have x plus 6. On the right I have 9. Then I'm going to solve this equation. So when I subtract 6, I get that x equals 3. So I'm going to check my answer. I'm going to put 3 in here. 3 plus 6 is 9. 9 to the 1/2 is the same as the square root of 9, which is 3, and 3 times 3 is 9. So this is the correct answer. I know at this point you may be wondering, why do I keep checking all of these when they all work out? So I'm going to show you a couple of examples of why we're checking these, because you are going to get some with extraneous solutions. So here's an example where I have the square root of x plus 18 equals x minus 2. So my rule is to get the radical by itself. I want to isolate it. That's already done. Next, I would raise both sides to the power that matches the index. Since nothing's written here, that's a 2. This is the square root. So I'm going to raise both sides to the second power. I have to make sure I do the entire quantity to the second power. Please remember that x minus 2 squared is not x squared plus or minus 4. We do not distribute the exponents. This is wrong. X minus 2 squared is the same thing as x minus 2 times x minus 2. So on the left, when I take the square root and the square, those cancel out. I have x plus 18. On the right, I have x minus 2 times x minus 2. So if I expand that out by distributing or foiling, then I have x squared minus 4x plus 4. Now I'm going to move each of these over to the right side, because anytime I have an equation where I have an x squared, I want everything on one side and 0 on the other side so that I can factor it and solve. So when I move this over, I had x squared. I subtract x, so negative 4x minus x is negative 5x, and then I subtract 18. So 4 minus 18 is negative 14, and that entire thing is equal to 0. Now I can factor the left side. So this would factor into x minus 7 and x plus 2. Now I can set each factor equal to 0 and solve. So if I set this equal to 0 and this one equal to 0, that's going to give me 2 answers. Remember, anytime you have an equation with an exponent, the exponent tells you how many answers you should have. So I get that x equals 7 and x equals negative 2. So we're going to check our answers. So first I'm going to put 7 in for all of my x's. So when I put in 7, 7 plus 18 is 25. The square root of 25 is 5. So I have 5 on the left. On the right, 7 minus 2 is 5. So I have 5 equals 5. So this answer is perfectly fine. Now we're going to substitute in negative 2. Negative 2 plus 18 is 16, and the square root of 16 is positive 4. Over here, when I put in a negative 2 minus 2 is negative 4. So I have that 4 equals negative 4, and that is not a true statement. So This is my extraneous solution. I still want to see all the work that shows that you came up with it, but then I also need to see that you've crossed it out because that's not going to work. That's your extraneous solution. So here's another example that will work out to have an extraneous solution. So here's one that I want you to try on your own. So play it when you get the correct, or when you get an answer, but pause it for now. Alright, so you would take both sides and square it because the index was 2. On the left, that would give you 2x plus 14. On the right, remember, we do not distribute the exponents, so that would be x squared plus 6x plus 9. Now I'm going to move everything over here. So I have x squared plus 4x minus 5 equals 0. Then I'm going to factor the left side. This one factors into x plus 5 and x minus 1. Then you would set each of your factors equal to 0 and solve. So I would get that x equals negative 5 and positive 1. Now when I substitute, when I put in a negative 5, 2 times negative 5 is negative 10 plus 14 is 4. The square root of 4 is positive 2. Over here, negative 5 plus 3 is negative 2. So positive 2 does not equal negative 2. Negative 5 is an extraneous solution. Now I'm going to substitute in 1 and check that one. So 2 times 1 is 2, plus 14 is 16. The square root of 16 is 4. On the right, 1 plus 3 is 4. 4 equals 4. That's true. So our only answer that we are keeping is that x equals 1. So I know that's kind of a lot of examples that we've gone through, but hopefully by going through each of these examples, that'll give you a good idea of how to work out all of the problems on the homework to the right.